Did you get my email about retaking a test? Did you get my email about, are we allowed to retake tests?
You are,
No, I'm just devastated.
and I did not get an email from you.
No. Through the Blackboard system. Right. Right, I admit, knowing me, it's probably went to my draft folder and I thought I sent it. What do I have to do?
Fill out the form like you would a quiz.
I haven't done this before, so,
The form's available on Teams.
okay.
You'll see it right up on the top.
And then how's it work?
I'll email you. Once I get the form and I approve it, I'll email you.
Because, what, next Wednesday is it, right? Is that it? Is that the last day?
I have a couple more weeks.
Oh, we do?
Yeah.
Okay.
Next Wednesday's our last meeting. After that's the final. The grades are due the 16th, so I'll probably just give you until then to make stuff up. Except for quizzes, so I'm not coming on campus.
Can I please, can you please do one of the things from the homework? There was a lot of stuff on that homework that I couldn't find in the book or the videos or anything. And I really busted my ass to get a failing grade on it, and I'm starting to freak out because I scoured the book, but I mean, when they say like, you know, if the cosecant of u is like negative some decimal value. And I couldn't find anything anywhere, you know, if the secant of u is negative, say, negative 1.628, and in quadrant 3. Everything I found in the book was like just pi over 3. I couldn't find any examples where they were giving you a messy decimal value for cosecant or secant. And I don't know, I'm going crazy because I tried everything that I could look for. I mean, if even I have this book, I don't know how much time you've ever spent looking at this book, but if you could show me where to find this stuff, I'd be happy because I'm really losing it. But I mean, could I just jot it on the board? Probably take you all of a minute to go through it.
I have no chalk.
Okay, I mean, I can.
And I don't-
Specs.
And because of my allergies, I don't touch chalk.
Okay, I understand. All right. I mean, could I do, it's just real short specs. You could maybe just do a quick run through up there, please? Because I'm at my wit's end, man.
It was what assignment?
Well, it would be 24, I guess. It would, you know, it's the one it's technically due tonight, but, then I'll be going home to try it again later, but
What
I'd
number?
be spinning my wheels. Well, for example, say 14 on the first run through. That involves, they give you the secant, and I just don't know what to do. I was able to do some of the ones where they gave you the cosine, but it's with the cosecant and secant as just messy decimal values.
So if U was in quadrant 3, what quadrant is U over 2 in?
Well, U over 2 is gonna, well, it'll either be in quadrant 2 or quadrant 1. If you cut it in half. Right, if U is in quadrant
If
3.
U is in quadrant 3, then U over 2 is what? We did something like this, I believe.
I do remember that, but why aren't there two possibilities? I mean,
So what's quadrant 3? What are the angles?
pi to 3 pi over 2.
Divide those by 2.
Okay, it's gonna be, all right, U over 2 is gonna be in quadrant 2.
What's the sign of cosine in quadrant 2?
That's gonna be negative.
That's why you're wrong. You have the right magnitude, but it should be negative, not positive.
You mean I got the right number, but
Yep.
I had,
But you're in the wrong quadrant. It should be negative, not positive.
Okay, all right, I'll ask you some more after class, I guess. That set just drove me out of my mind.
So just to refer back to that one. So literally, as far as setting up my triangle, I mean,
You did everything right.
yeah, but I just, okay.
You were just in the wrong quadrant. So just because it's a decimal doesn't mean you change anything you do. The thing is, obviously, you're just gonna have an approximation now. You can't get an exact answer.
I know, and given my past experience with that, traumatized.
Very rarely will a problem slip through me in the homework where you don't have the tools necessary to do it. May look different, but you have the tools necessary to do it. There is a rare occasion where it does slip past me and it's something that cannot be done. That has happened, but for the most part, it's something that you know how to do. It just looks different. Right? Easier said than done, but don't panic. Because then you do get it wrong. Just take a deep breath and tell yourself you know how to do it. I don't know why I never took more psych courses.
I don't know if you have.
That stuff interests me. We'll see if I have time at the end. I would like to actually just be able to finish everything today, but I don't think I'm gonna be able to. We'll see. Happy Monday. Getting to the end. We have two more identities to look at. Product to sum and sum to products. There are, I believe, 4 product to sums and 4 sum to products. Okay, there they all are. Cosine of alpha times cosine of beta is going to be 1/2 quantity cosine of alpha minus beta plus cosine of alpha plus beta. Sine of alpha times sine of beta is 1/2 sine of, 1/2 the quantity cosine of alpha minus beta minus cosine of alpha plus beta. Should be plus, this one's minus. Sine of alpha times cosine beta, 1/2 the quantity sine of alpha plus beta plus sine of alpha minus beta. Then you also have cosine of alpha sine of beta, which is 1/2 sine of alpha plus beta minus sine of alpha minus beta. Bless you. Keep in mind, of those last two, you actually need one of them. Right, sine and cosine are commutative. I'm sorry, product is commutative. So sine alpha cosine beta and cosine of alpha sine of beta, sine of beta times cosine of alpha would be the same. Also, sine is odd. So if you just flip the order, you could write it as sine of beta plus alpha plus sine of beta minus alpha, which gives you the first identity. And then finally, we have the four sum to products. Sine alpha plus sine beta is 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. Sine of alpha minus sine of beta. Two sine of alpha minus beta over 2 cosine of alpha plus beta over 2. Then you have cosine of alpha plus cosine of beta, 2 cosine of alpha plus beta over 2 cosine of alpha minus beta over 2. Their difference, cosine of alpha minus cosine of beta, it's just the signs. 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. We now have all of the standard trig identities that you'd find on a standard trig sheet. May want to keep all of these handy, even in future classes. All these identities can make your life a lot easier in calculus and beyond. Going to prove sine of 4a plus sine of 2a over cosine of 4a plus cosine of 2a is tangent of 3a. Use the sine sum to product. Two times sine of 4a plus 2a over 2, sine of 4a minus 2a over 2, I'm sorry, it's cosine. The cosine, sum the product 2 cosine 4a plus 2a over 2 times the cosine of 4a minus 2a over 2. Two over 2 is 1. Four a plus 2a over 2 is just 3a, so we're left with sine of 3a. And then denominator, we're going to be left with cosine of 3a, right? Because notice, those terms are the same. So that's also 1. But sine of a cosine. It's just tangent, so we have tangent of 3a as desired. To prove that sine of a minus sine of b over sine of a plus sine of b is tangent of a half a minus b over tangent of a half a plus b. They're going to use the difference to product for sine. Two times sine of a minus b over 2 times cosine of a plus b over 2. The sum two times sine of a plus b over 2 times cosine of a minus b over 2. Two over 2 is 1. That's sine over cosine. I'm just going to write it this way. Then we have cosine over sine. Which is cotangent. Cotangent is 1 over tangent. And so we've achieved our desired result. Prove cosine cubed times sine squared. 1/16 of 2 times cosine minus cosine of 3x minus cosine of 5x. Cosine cubed can be written as cosine times cosine squared. Cosine squared times sine squared can be written as cosine times sine all squared. Cosine times sine. Half of sine of 2x. Right now we have a quarter cosine of x times sine squared of 2x. Use reduction identity on sine squared. One minus cosine of 4x all over 2. That'll leave us with 1/8 cosine of x minus 1/8 cosine x times cosine of 4x. Use product to sum for cosine. Be 1/2 cosine of alpha plus beta plus the cosine of alpha minus beta.
Okay, I'm sorry, can you back up for a second? All right, I see where the 1/8 comes from. Where did cosine x times cosine 4x come from? Oh, wait, distribute.
Has to distribute, yep.
Is it, wait. Yeah. Cosine.
They're the same thing, are they not?
Yeah. Oh,
So 1/4 cosine x distributes into both of those terms.
okay.
Eighth times a half is a 16th. Parentheses, we're left with cosine of 5x plus cosine of negative 3x. Shoot the negative 1/16 through. Now factor out a 1/16. I'm also going to reorder. Right, it is 1/16 2 times the quantity 2 cosine of x minus cosine of negative 3x minus cosine of minus cosine of 5x. You're so close. But remember, cosine is even. So cosine of negative 3x is the same as cosine of 3x. We now have what we want. One plus cosine of 2x plus cosine of 4x plus cosine of 6x is equal to 4 times cosine x times cosine of 2x times cosine of 3x. For cosine of 2x plus cosine of 4x, do product to sum. That's 2. Cosine of 2x plus 4x over 2 leaves with cosine of 3x. Times the cosine of 2x minus 4x over 2 leaves with cosine of negative x. Addition is associative and commutative. I'm going to group 1 plus cosine of 6x together. Cosine is even. So cosine of x is cosine of negative x. Right now we have the quantity of 1 plus cosine of 6x plus 2 cosine of x cosine of 3x. One plus cosine of 6x. If I were to divide that whole thing by 2, we would have the reduction identity for cosine. So that's 2 cosine squared of 3x.
Wait, what happened to 1 plus cosine 6x?
If you divide that whole thing by 2, right? 1 plus cosine 6x all over 2. That's the reduction identity for cosine. But that'd be cosine squared of 3x. Since we're not dividing it by 2, it's being doubled. That'd just be 2 cosine squared of 3x. We now have a 2 cosine 3x common. Factor it out. Left with cosine of 3x plus cosine of x. Use sum to product identity again. That becomes 2 cosine of 3x plus x over 2, 2x, times cosine of 3x minus x over 2, which is just x. Multiplication is commutative. 2 times 2 is 4. And then we can rewrite this in any order we want. Four cosine x, cosine 2x, cosine 3x as desired. OpenStack saved. That's odd. Wish to evaluate this exactly. Cosine of 45 degrees times cosine of 15 degrees. I don't know why I wrote sine. Cosine of 45 degrees we know, right? Root 2 over 2. What about cosine of 15 degrees? That is not known. So let's try product to sum. The 1/2 times remember it. Okay. Cosine of their difference. Is it plus? Yes. Plus the cosine of their sum. Well, we know cosine of 30 degrees, right? What is cosine of 30 degrees? What is cosine of 60 degrees? Value is root 3 plus 2 all over 4.
Plus.
No, it should be root. I'm sorry, root 3 plus 1.
Yeah.
All over 4. I don't know where that 2 came from. Two sine of 100 degrees times sine of 20 degrees. Product to sum. You have 2 times a half, which is 1. Perfect. Product to sum for sine. Cosine of the difference minus cosine of the sum. Cosine of their difference minus cosine of their sum. Cosine of 80 degrees. Would be what?
Oh. And you can use what, your sum product? And change cosine minus cosine into that two sine.
Well, I just did that, except I did sum the product, so
Oh,
it
shit.
would defeat the purpose of going back. Has no exact form. So leave as cosine of 80 degrees. You can't even write 80 degrees as a double angle of a known, right? It'd be 2 times 40. That doesn't work. Can't write as a half angle. Be 160 over 2. 160 is not a known angle. You cannot write it as the sum or difference of known angles. You can get pretty close. Right, so 60 and 20 would work, but we don't know 20. So that kind of leaves it more complicated than before. 30 and 50. 30 is known, 50 isn't. So just leave it. Cannot be simplified. What is the cosine of 120 degrees? Right, 60 plus 60, but 120 is actually a known angle,
Oh,
I think, right?
yeah, reference angle is 60 here, so it's, yeah.
So it's cosine of 80 degrees plus a half. And you'd leave it that way. Trig equations. Unlike other equations that we've solved, where, like for polynomials, you could have multiple solutions, but they were finite. Right? Logarithmic, you could have multiple solutions, but it was still a finite number. Same thing with exponential. Right? All of the equations we've looked at so far had a finite number of solutions. Technically speaking, trig equations can have an infinite. In fact, they will always have an infinite number of solutions if they have a solution, because the trig functions are periodic. For the most part, we will only be dealing with solutions in the interval of 0 to 2 pi. Be sure to read the question and instructions carefully. Let's start by solving some simple ones. All right, so we look at 2 sine of x minus 1 is equal to 0. The idea is the same. You want to isolate your x. 2 sine x would be 1. means sine of x is a half. This is where things are different. You cannot take the inverse sine of both sides. Right, remember, we restricted the domain for sine to make it 1-to-1. So we could define an inverse sine. That means inverse sine is not going to give you all possible solutions. It's only going to give you one. What you have to do is you have to look at this and you have to ask yourself, over 0 to 2 pi, right? Because that's the interval that we're looking at for this problem set. Sine of what angles is 1/2? There's your solution set. Sine of x times cosine of x is equal to 0. Bless you. Two ways we can go about this one. I'm going to go the obvious route. We have the product of two functions equaling 0. Remember, the 0 property. If you take the product of real numbers and get 0, that means at least one of them must be 0. I am just not going to write out or anymore. I'm going to use the shorthand. So sine x is 0 or cosine of x is 0. Start with sine x being 0. Where is sine equal to 0? Or is cosine equal to 0? Our solution set would be the union of these two sets. Right? Union because there was an or. If there's an and, there'd be an intersection. Again, dealing with a product. Tan x minus 1 is 0, or 4 sine squared x minus 3 is 0. Means tan x is 1, or sine squared of x is 3/4. Which means tan x is 1, or sine x is negative √3/2, or sine x is √3/2. Where is tangent 1? Where is sine of x negative √3/2? Is sine negative there?
Oh, no. Negative. Oh, negative. Four. Five pi over. No, wait. 5 pi over 3? Four pi over 3?
4 pi over 3 and 5 pi over 3. Where is sine positive √3/2? Once again, your solution set is the union of those. I think 5 pi over 4 is smaller than 4 pi over 3.
Oh, yeah.
Doesn't matter. I just like to have it in ascending order. And so there's our solution set. Four. Sine squared plus sine minus 2 is equal to 0. Do a change of variable. Let y be sine of x. Then we can write it as y squared plus y minus 2 equal to 0. Isn't this quadratic? Can it be factored? Or is it factor 2?
20y plus 2. Y minus 1.
We get y is -2 or y is equal to 1. That means sine of x is -2 or sine of x is 1.
Check.
Sine can never be -2. Where is sine equal to 1? Sine is 0 at those 2 points.
Oh, of course. Yeah, pi over 2 and 3 pi over 2.
What's sine of 3 pi over 2?
It's negative.
We have a single solution. X is pi over 2. Three cosine squared is equal to sine squared. This means that tangent squared is equal to 3. Means tangent is -√3 or tangent is +√3. Where is tangent -√3? Divided both sides by cosine squared.
Is it, pi over 3? Wait. Oh, no. Wait, I'm sorry, which one are you asking about?
Negative root 3.
Oh, negative. 2 pi over 3. The pi over 3 is gonna be for the positive one. 5 pi over 3, right? You add pi to it. Go halfway around the circle.
Where's tangent root 3? He totally threw you under the bus
Why?
because there's a second answer. What is it?
Goodbye.
You get bonus points for this.
You want to add pi to it, only in terms of over 3. So instead of 1 pi, it'd be 3 pi over 3. So add 3 pi to the numerator, right? Isn't that, am I saying it the right way?
Do you understand it?
Well,
So
like
what's
when
the
I,
second answer.
when I went from 2 pi to 5 pi over 3, I added 3 pi over 3, or 1 whole pi, to get halfway around the circle.
So it would, so you said if you would add 3, so it's 3 pi over 3?
Well, I add 2, the first one. You add that to the pi over 3 to get halfway around the circle from that.
So 3 pi, so 2 pi over 3. No,
No, pi over 3 and then add 3 pi over 3 on top of it. Sorry. Because you added 1 whole pi, but you described it as instead of 1, that's 3 over 3.
Yeah.
That is not how I did it, but yes, that is valid.
I feel validated.
I look at it in terms of quadrants. Negative quadrant 2 and 4. I know pi over 3 is my reference, so I get 2 pi over 3, 5 pi over 3. Positive gives me quadrants 1 and 3, pi over 3, and the reference angle in quadrant 3 is 4 pi over 3. That's how I do it. I don't even think in terms of circle at all. I just think of quadrants. Solution set pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So they were all what I would consider the easy ones. Now we're going to get into the medium. We're going to get into the moderate difficulty ones. Two sine of x minus cosecant of x is equal to 1. Multiply everything by sine. Okay. Or factor out the 1 over sine and multiply both sides. Same thing. That means that 2 sine squared minus sine minus 1 is 0. Let's let's see equal sine of x. One of the coolest Greek letters.
Almost expect you to write "Don't tread on me" around it. God.
Is that process what you said? Is that actually?
It's a Greek letter, yes. Interesting trivia.
Square. One.
So there's the letter.
Very interesting.
C. That's how I have always heard it pronounced. C or C is the Greek letter before Omicron. Yet we did not have a C variant. Why is that?
Newscasters couldn't pronounce it.
Look at how it's spelled. Looks like the last name of a certain Chinese president.
Oh,
That's why they skipped it. They didn't want it to be confused because it is a common last name. And even though it's the Greek letter, that's a common last name. So they skipped that one and went to Omicron, which I never knew was actually a Greek letter. For some reason now it's not working. Why is it not working? I know it's a Greek letter. It's right there. I'm spelling it right. But it doesn't want to do it. Okay, whatever. This looks like an O. Can that be factored? What is it factored to?
2C plus 1. No. Yeah, plus 1 times C minus 1.
C is -1/2, or C is 1. Which means sine of x equals -1/2, or sine of x is equal to 1. Where is sine -1/2? What is it? I'm hard of hearing. I'm old.
7 pi over 6.
Where is sine equal to 1? This one everyone should know.
Shit, did I mix it up again? Wait a minute. No. Sine? Oh, 1. How did I get them backwards? Pi and 3, pi over 2, 3 pi over 2. But no, it's can't be, yeah, it's just pi over 2. Just
Our solution set: pi over 2, 7 pi over 6, and 11 pi over 6. Two secant is equal to tangent plus cotangent. Multiply. Let's multiply 3 by a cotangent. Two cotangent cosecant equal to 1 plus cotangent squared. 2 cotangent cosecant. I'm sorry, cotangent secant.
One over sine, which is the cosecant. Right?
What's 1 plus cotangent squared?
Tangent square. Plus, what was it?
1 plus cotangent squared. Cosecant squared.
Wait, so that's one of the we come from the Pythagorean.
Yes, that's one of the 3 Pythagorean identities.
And I guess I wrote it down. It's 1 plus cotangent squared equals cosecant.
Yes. Or cotangent squared plus 1 is cosecant squared, doesn't matter.
Yeah.
Cosecant can never be 0. So we can divide both sides by cosecant. Cosecant is equal to 2. Means sine of x is a half. Where is sine equal to 1/2? So where does sine equal 1/2?
Pi over 6. Pi over 6.
There's a solution set.